Hello and welcome to the next in our Insider series. This is a series where we take a peek into the leading doctoral research centers around the world does a kind of fly on the wall documentary, as it were, to go and see what kind of research has been undertaken there. We've already had on this series some very distinguished, established institutions, MIT Media Lab, ICT Stuttgart, ETH Zurich, Tongji, UCL Bartlett. And next semester, we will be starting, next January, next month, we will be going to Harvard GSD. This session, though, is on a let's say, an outsider, shall we say, an outsider within our Insider series, in the sense that it's a very new program and one that is trying to reconfigure the notion of doctoral research. Before I introduce the FIU DDes, and I should say my name is Neil Leach, I'm the director of the FIU DDes. I just want to make a couple of announcements about what's happening this week. Firstly, we have a session on the 17th of December in Portuguese, and followed by a session on the 23rd of December in Spanish. Digital Futures itself will be taking a break over Christmas and New Year. The FIU campus is located about 20 miles west of Miami itself, quite close to the Everglades. It's a very new campus, and indeed, this is the Paul Sejas School of Architecture, which has only recently been completed. FIU's the School of Architecture itself is only 25 years old, and the FIU DDes program began in 2021. In other words, we're talking about a very young School of Architecture and a very new program. The building is the FIU is housed in this extraordinary building designed by Bernard Tschumi that in many ways represents what Miami is. It's a building with gateways, with walkways, with staircases and so on, which in the style of Bernard Tschumi, the architect, is a way to try and make it into an event space, a meeting place where informal conversations take place on all these walkways and staircases. And that in some ways represents Miami itself, a city that is at the crossroads, shall we say, of east and west, north and south, the gateway to Latin America, often referred to as the capital of Latin America. Indeed, the dominant language in Miami is Spanish. And Bernard Tschumi, with his approach towards architecture, very much echoes the approach of the school itself. Several people have worked with Bernard. I myself taught at Columbia when Bernard was the dean there, and Bernard was invited to design this building. And Bernard himself represents a certain approach towards architecture. Let's say a very progressive one. One is continually looking for new approaches. One that is also very theoretically informed. And finally, one that is also very receptive to these new technologies. So this then is the building where on the main campus where the FIU School of Architecture is housed. And this year is the 25th anniversary, and Bernard will be coming in February of 2023 to give a lecture on the main campus. What makes the FIU DDes so distinctive is that it's very unlike other programs. Most PhD programs, you attend and join a lab, and you're there the whole time. This one is designed to operate remotely, primarily designed for academics who are in post already, to allow them the flexibility of keeping their post, but also putting together the research towards a doctorate. That makes it quite distinctive in the sense that it's a largely online program where we meet once a semester as a group, but it's essentially mainly online. What also makes this program very distinctive is it takes 15 credits from the master's program and counts it towards the overall doctorate. In other words, instead of doing 60, you do 45 plus 15 credits for your master's, which reduces it down to 2 years, a very intensive 2 years, but 2 years nonetheless, although it can expand beyond the 2 years. There is the opportunity, however, for those who are interested in coming to Miami itself and being located in person on campus and making use of the Robotics and Digital Fabrication Lab, the RDF Lab, which has only just recently opened, where Madeleine Gannon, one of the famous figures in the world of robotics, and herself a graduate at FIU, is undertaking her research. So it's a program intended primarily for those who are operating remotely, but it can be operated at a more in person itself. Alongside the main campus, FIU also has a series of outposts, including one in Miami Beach, Miami Urban Studies, Miami MBUS, Miami Beach Urban Studies. And here's John Stewart, who directs the program at FIU on MBUS. And once a semester, we come together in Miami Beach for a progress review and take part in the extraordinary life of Miami Beach itself, trying to tap into the vitality and indeed the magic of this particular place. Miami Beach, for those of you who don't know, is of course famous for its Art Deco buildings, but increasingly it's becoming a kind of playground of architecture with a whole series of buildings by all the leading companies. Zaha Hadid Architects, that's up in Moran, OMA, Big, and so on. It's really in many ways turning into an architectural mecca. And MBUS itself is located opposite the Frank Gehry's concert hall in Miami Beach, but on the same road is the extraordinary parking structure, 1111 Lincoln Road by Herzog and de Moran, a parking structure that reinvents parking structures, a parking structure that in many ways it represents the way that we're trying to reinvent doctoral education. It's an extraordinary structure. On the roof, there's a penthouse suite. On the ground floor, a series of designer shops. And in between, this extraordinary structure that has been able to host things from weddings themselves to other kinds of events. So it becomes a reinvention of the possibility of what we can imagine in a parking structure. Also in Miami, there are a number of other buildings that are very significant. Zaha Hadid, in fact, this is the apartment that Zaha Hadid designed for herself, for Claudia Bush, one of my colleagues, who is very close to the Zaha office, as indeed many of us are. This is located in the W Hotel, and tragically, of course, Zaha was in Miami when she died a few years ago. Miami, you can understand, at this time of the year, it's been 27 degrees and sunny all week, and you can imagine that it's a wonderful place to retreat from the cold and the gloom of London and other cities around the world, especially in the Northern Climes. And this is Patrick Schumacher giving a talk about Zaha and her presence in Miami Beach. And of course, very recently, 1000 Museum, the tower designed by Zaha Hadid Architects, was opened, which really has transformed the skyline of Miami itself as a kind of extraordinary new addition to an extraordinary list of buildings. In these sessions that we hold, we live stream them so that we can share the material with others who are unable to join. And the idea is that these are part of what we call the doctoral consortium, whereby instead of individual students meeting their individual professors, we offer a shared platform where everyone around the world can join in and follow what's going on. So it becomes some kind of global brain. This was then a session that Patrick was doing, talking about his work in Miami, and also Zaha's other designs for Miami. We also had a series of sessions which you might have seen on digital futures as part of the same initiative, Doctoral Consortium initiative. This is a series from the fall of last year, architecture and philosophy. And I'm just showing you what maybe the most important or the most significant session, I would say, in that series, a session on the French post-structuralist philosophers, Jacques Derrida and Hélène Cixous, where we brought together two key architectural figures, Bernard Tschumi himself and Peter Reisman, both of whom had been working with Derrida, along with Doina Petrescu, who herself was a PhD student under Hélène Cixous and a master's student under Jacques Derrida. And for the first time, we brought together the key people to discuss the significance of these two extraordinary French figures. Also on this part of the doctoral consortium, we had a series this spring on AI, neuroscience and architecture, where we brought in some of the extraordinary new figures at the interface between neuroscience and AI, and then interface between academia and the commercial practice itself. We had Jeffrey Hawkins, the inventor of Palm Pilot, who has his own neuroscience establishment now. We had Joshua Bach, who is one of the leading figures looking at the crossover between neuroscience and architecture, Benjamin Bratton, David Chalmers, Susan Schneider, Andy Clark, and others, which really was, I think, an amazing series where we could see a new a kind of theoretical paradigm appearing with some extraordinary new ideas. And then we also, this semester, many of you would have seen the AI Spring series, where we were looking at the way in which 2022 is really the moment in some senses when architecture woke up the possibilities of AI and as a whole, both because of the diffusion platforms that have become so incredibly popular, and also because of the books that have been published. And we had a number of sessions on those different books. One of the main the main sort of topics that have been pursued in the DDes is, of course, the notion of AI, something that's been very prominent, and we'll hear later from Philippe Morel and also from Van Yu He about their research. And this is a session that we put together with Will Prix, looking at and this is the Deep Himmelblau project that he presented. I'd also mention Theodoros Galanis, who has been part of this program, who was responsible for writing various environmental AI software, including infrared. And alongside that, there's also an interest in other forms of new technologies. New technologies. This is Sumin Ham, who's also on the program, and is in front of her steampunk pavilion in Tallinn. Sumin is working on the notion of the augmented architect. You can look at the use of AR and other techniques to open up an agenda about architecture. So advanced technology is an important part of one of the main themes of the research that's going on. Also in the research, another theme in the research is the environment itself, sustainability. And Miami, of course, is a city that is at threat of global warming and sea level rise. And finally, the third sort of area of research is in the kind of the theory, in the area of theory, history, theory, and criticism. And there are a number of doctoral theses that have been written in this particular area. And these, of course, are all slightly different. The way in which you write a scientific research thesis is slightly different from the way you might write a humanities-based one. And we also allow for the possibility of a design-based thesis. That's the reason why we called the program a DDes rather than a PhD. Effectively, they're all the same, but the DDes allows the possibility of a design component in the work itself. So this then gives you an overview of the DDes. It's a program that's designed to be deliberately flexible, that's open to new ways of operating, that's trying to reinvent what it can be to be a doctoral candidate in the 21st century, looking at novel ways of putting it together, allowing the flexibility of studying remotely or being in person. So I've put here, this is the QR code that if you do a screen capture and then scan this code, this will take you directly to the website for the FIU DDes. So let me say something by way of introduction to our very distinguished group of contributors today. Let's start with Philippe Morel. Philippe Morel is no stranger to anyone who's been operating in Europe, especially in London and Paris. He's one of the dominant theoretical figures. He's currently a professor at UCL Bartlett, and he has his own practice. He's at CT, a design practice, and also X3E, where he is has a large scale 3D printing practice. And of course, Philippe is also known not only as a theorist, but also as a designer. And he was the winner, for example, of the famous Sarusi Pavilion competition, where many of the most progressive firms in the world took part. Van Yu He is a graduate of the Berlage. She worked for OMA for 8 years, I think, in Hong Kong and Amsterdam and Rotterdam. And she's now the CEO of XCool. The term ex-Koolhaas, of course, refers to experience in OMA. And XCool has become probably the leading AI software developer alongside Autodesk. XCool is based in Shenzhen in China. Matt Gorbett is a graduate of MIT Media Lab. He's a Canadian, and following his time at MIT Media Lab, he went to work with Park Xerox, and he's since then he set up his own design company and is now working with Philip Beasley on his living architectural systems in Canada. Aya Riyad is graduated from the American University in Cairo. She went on to study at the AADRL, like many of the members of the cohort. Came back to the Middle East, is now a professor in Dubai. Bhavlin Kaur is from India. She studied at both in Portugal and also in the Elisava School in Barcelona in Spain. She has been a professor in Mumbai in India and is now in person in Miami itself, working in the RDF lab. Felice Grodin is a graduate of Tulane University and then Harvard GSD. She is operating largely as an artist these days, but is also an adjunct professor at FIU, and she's also on the FIU program. Leela Wu is one of the, I think also articulates the very international kind of composition of our lineup. Leela is originally from Macau. She studied at Chinese University in Hong Kong, at the Angewandte in Vienna, and at SciArc in California. She has been an adjunct professor at both the College of Architecture and Urban Planning in Tongji and also the Department of Design and Innovation at Tongji, two schools that we featured on our last Insider series. And she is responsible for setting up a materials library that has been highly influential with clients such as Adidas and Gucci and so on. Finally, Barak Chamo. Barak is from Israel. He is an interactive designer and engineer, and he is an adjunct professor in two different departments in New York, including at NYU. And he's also been part of the Team Lab interactive practice in Tokyo in Japan. So these are this is the lineup that we have. I'd like to invite Wan Yu to, well, the order is going to be Wan Yu He, followed by Philippe Borel, followed by Aya Riyad, followed by Matt Gorbe. And I'd like to invite Wan Yu to share her screen.
Yeah. Thanks, Neil. Can you see my screen?
Yes.
Yeah, I gotta do the full screen. Is the full screen working?
Yes.
Okay. Okay. Hello, everyone. I'm Wan Yu He. It's a very honor to be here and to introduce my doctoral project in FIU. Actually, the doctoral project is the design doctor. So actually, in the first beginning, I was wondering what is the design doctor. So my question of the program or this project is starting with what is design in terms of architecture, of course, because my background and this program is about architecture. And the more specifically in the area of architecture, artificial intelligence, because as we know that we all know that AI is already the main driven power of current technology. So this is my question. But about the question of the design itself, by a traditional way, Hermann Hertzberger was answering as architectural design is about thinking. And through a process of questioning, information analysis, and issue confirmation, positioning, argument, scenario, solution, and finally is the scheme. So when I was architect, I met a lot of young architects, and also when I was teaching in Hong Kong U for the Masters of Urban Design, I found a lot of students also, when they think about design, they immediately jump into the scheme, to the representation, which means in architecture, they do drawings. But the above, there's a lot of thinking, analyzing, positioning arguments. They kind of are not so into it. But what I want to find out is currently AI can help us do a lot of things, but can AI do the above thing, the thinking, let's say, to do the questioning and analyzing, issue confirmation, positioning, argument, scenario, etc. When I start my research, as you may know, that my company, School, we are using AI technology to do the design. And we found out, yes, AI can do a lot of things about the representation, analyzing, but the middle part as the issue confirmation, positioning, argument is so difficult. So I will start with this question, and my methodology will go through this traditional way of design, which is kind of, let's say, operational research, which we try to find the balance where we do the extreme of the things we understand from the question through the analyzing. So I did something interesting with the currently very popular, actually it's just a few days ago, the OpenAI just announced their latest AI program called ChatGPT, which is a AI you can talk to it and it can answer you. So I started my analyzing currently with this thing. It's very funny. I asked it this question to the AI. So the green part is the answer by the OpenAI. What is the architectural design? It gives a very traditional way of answering, which is totally different from what Hermann Herzberger and I explained in last pages. But when I add on in the era of AI, then the AI answered totally different, because it start to think in the AI era, the architectural design is being impacted by use of the AI technologies in a number of ways. This phrase is totally, I just saw the AI typing like one word after another. So it's so inspiring. Actually, it is the truth of right now. We are trying to do so. And I asked the further question, can you give an example of it? So the AI answered, the AI need to be used in a generative design. Yeah, I think that is the most fair answer so far. And also I asked for the methodologies, which is somehow in coincidence, or it is the answer that is totally similar to what we do in School. Later, I will explain this part. And this model of the ChatGPT is the kind of a new model add-on to the reinforcement learning. It's called the reinforcement learning from human feedbacks, which means we, as human beings, we also do inputs to train the model. It's kind of like the imitation learning. And that is the human can do demonstration to help the machine to understand how people works, and trying to find out the regulations or rules or laws behind it, and involve its own algorithm. And by so far, there's already a lot of types of generative models like GAN, VAE, diffusion model, or flow-based model. There's quite a lot. And those are the existing things through a lot of the literature review. We can also find out those answers. And I also read quite a lot about the Foucault, and my issue was conclude that currently the design also in Foucault's context, called the town, will not be conceived or planned according to static perception. This is the old way of traditional way of doing so. But Hay was arguing it should not be like that. It should not be exactly controllable, not precisely measured or measurable. And this particular answer actually can be answered today. A particular question can be answered today, which is with AI, we can really organize a kind of system to refer to those problems of security. And yeah, and what his conclusion about this is a milieu is something, is a kind of open series, can only be controlled or by estimate of the possibilities. So a space in which a series of uncertain elements unfold is roughly called milieu. So my question, my issue will be focused on this milieu. How can we design or build or create such a milieu to represent how the design process be processed on? So the key issue is, can AI create a milieu and test our idea of the design? Actually, there's already kind of a manual way of doing design. Here I'm showing some games because games is also a very interesting way of doing design, also with the very logical sequence of architectural. I mean, the architecture means a structure, its own logic stories. And in those games, we found out when people is playing those games, people tend to do something very clear purpose. But when it's go to the machine, it will turn out different story. For instance, for the game of life, you will eventually find the result are so random. So if the AI can create a milieu, yeah, my position is yes, we can do that, and it can do better. If the AI can do, but how can we do it? So it brings to me the argument that if we can design a system for AI, then the AI can work on its own to build a milieu. So this is the argument. I think this milieu can really works as the perfect, that's the so-called perfect design, which AI can help us to test through a system we can design for it in the beginning, which is we somehow understand, or not somehow, which is based on our understanding of the difference and the similarity of human interactions with AI interactions. We both do inputs, process, and outputs. And for the human beings, we have a lot of ways to do the input, and we do thinking, we do feelings, and then we do the actions. But for the machine, for the AI, we need to have a kind of characters and behavior patterns to be interact with the environment, and also get the feedbacks, so-called the rewarding system of the AI. And in which I start to draft this milieu thing. We have a target. We should have a target for the milieu. There's a kind of purpose, or even random purpose. That is also kind of purpose. We need to have the input or the targets, and then we have the algorithms and the data to be trained. Eventually, we can find out what it can deliver to us. So the scenario is going to be the video is kind of a presentation in the way of the kind of metaverse in the virtual world, with the characteristic of the AI and IA, meaning for the intelligence agencies. That is the kind of the actor of the system, representing human, but it's not really the avatar of human or meta-human. It is the agencies, which is have its own intelligence, and the video background or the scenarios based on the moon or Mars, which is something fun for me. And I think that is a place we can test if in the extreme condition, what can we do? So I planned this structure of the I call M with the agents, behaviors, interaction, technology, typologies, and the environment, time and update mechanism and feedbacks. Because of timing, I won't go too far of this, but I would like to explain how the solution gonna work with this system. The AI can do 4 kinds of things based on my previous research in X-School, which is the discrimination, evaluation, reconstruction, and generation. I won't go too far of this, but somehow, sorry, this didn't play, but I have a second one of the discrimination. This is in our X-School platform. which you can just input your CAD file, and we can discriminate the elements. For instance, the door, you will be recognized as a door with the meaning of it, and you can change the meaning of the door, and the door will be changed, which is a very practical way of using discrimination, not just in researchings. Sorry, this one doesn't play. Yeah, and the secondly is the evaluation. This is something we did in Digital Future 2019, and we're using the data surrounding Tongji University. This data meaning the computer vision to discriminate firstly the street views, and then the machine will try to analyzing in a quantitative way to find out what is the issue of the streets. For instance, is it enough greenery, or it's not, or is there's enough openness? So this is the way to help us to do the evaluation. And but this way is using like AI, this kind of line and analyzing of the clustering of the algorithm models. But there's another way of evaluation is using intelligence agencies. You can see those small dots, they are intelligence agencies be identified with different characteristics. For instance, 25-year-old girl locally from Hong Kong, and she liked to take bubble teas and go to certain shops. And there might be thousands of these kind of intelligence agencies running randomly, they have their behavior patterns in this building and what they're gonna do and what is the effect on this building. And they will help us to get the evaluation of the performance of this design. Actually, this building is not existed yet. So this is the one way. And when we talk about reconstruction, oh, sorry, that one doesn't play. But maybe people think about this GAN to do the image reconstruction, but in a way we can also using the AI to do the facade reconstruction. This is one of the real project we did in with the Chinese LDI, and it was there was over 30,000 pieces of these triangular facade panels. And they even asked Gary Tech to test for them. It would take 116 pieces of panels to finish this irregular shapes or volumes. But we are not satisfied with the 116. So we're using AI to help to reconstruct the form and also the panels. Eventually, we got just a 12 piece of the panels to resolve this issue. So like 90% reduced. And for the generation, currently the diffusion model is quite popular. So we also did some researches about it, especially in the architectural way, which is we somehow grouped or analyzing the data and give it different tags of the architectural identities. For instance, the designer or materials and different programs, etc. And we build up information or connection through all those images and the texts to get our, we call it creation cool. And we did this Xcool robotic on our WeChat. So in the chatbot, you can talk to the AI, for instance, the small villa surrounded by water with green foreground and mountain background by Zaha Hadid. And it will give you this. And yeah, several images you can select. And I found those outcomes are quite good compared with the DALL-E or Midjourney. It's more like architectural styles. For instance, also this one with Tado Ando or the Roman Foster or Alva Alto, eventually the Frank Gehry. So those kind of ways can really works well. But as a company of Xcool, we're really doing serious AI-driven or AI-assist design tools. Like this one is the software online. You can do with AI. You don't have to. Oh, sorry. Yeah, like here, you don't have to like draw all the lines, building all the components by yourself. Like here, the AI will automatically adjust the form for you. Or here, you just input your ideas of the layouting. The AI will guessing, are you designing this kind of a layout of the flat? It will suggest you and recommend you, and you will take one bit, and then AI will help you to do all the internal layouts, also do the MEP and other details, the further plans. And as well as the go to the further step of the let's say construction. Here construction, we're meaning the prefab construction. Like this one is the MIC this kind of a way of doing construction. 95% of the components are standard and can be pre-cast in the factory. So it is very similar as the AI answered previously. We're analyzing all the 24 steps of design. And I mean, design here is the scheme. When we do scheme and the representation, there's a six steps of the procedures. But previously, we don't have 6 softwares to dealing with our 25 or 24 demands. Therefore, we have to use a lot of softwares to finish all our. Sorry, it's too long. Yeah.
Yeah. Could you try and wrap up?
Oh, sorry. Yeah. Yes. Sorry. Yeah. So we just compose this into one and make it much easier. And there's some examples we did, and then it's finishing. Yeah. And the next, I'm still continue with this research. So next time, I'm just gonna try to find out, can the AI design it by its own by imitation learning and RL, this reinforcement learning by human feedbacks. And there are some thing I did last semester to trying to find out those multi-agencies, how it can play, and when people try to play by person to train it and how it could work. So I won't go too far, but this is how in next we will try to find out how those things can work out on the triple M on the moon. So it's still undergoing. Yeah, I'm finishing. Neil, thank you.
Thanks, Wanyu. Thank you. Yeah. So I'd like to invite Philippe to share his screen. Philippe, welcome.
Hi, everyone. Do you see my screen? I assume so.
Yes.
Okay, perfect. Thanks a lot. So it's really a pleasure for me also to present this, the work I'm undergoing at the very moment at FIU as part of my PhD, or more precisely, my Doctor of Design program. So let me introduce quickly what I'm doing. As you all know, in fact, we are really at the very moment in experiencing a crazy revolution. And according to me, the main component of these revolutions comes from the birth of the computer, obviously, and also it comes from new paradigms that are finally, let's say, working extremely well. Indeed, artificial intelligence. In fact, artificial intelligence. So what I'm trying to do is to understand, based on the history of the computer, the history of the birth of the computer, and also the history of sciences that, let's say, created this, helped creating and shaping this computer, many logics. I'm trying to understand what is the nature of architecture at the age of superintelligence. So this is really what I'm addressing in my dissertation proposal. So I will go very quickly through a couple of things. So we experience, as I said, the situation in architecture and beyond. When we speak about architecture today, we address this in a very abstract way. we address, in fact, the issue of abstract intelligence. And this is what Nick Postra, for example, was dealing with based on some previous research, for example, by Alan Turing in his famous article, Computing Mastery and Intelligence. We experience a deluge of data. Everyone can see this every day. And most of this data come from smartphones and applications. It has to be known that by 2030, so more or less in 7 years, with so amazingly short at the scale of humankind, it's just like a pen at that scale. We more than 90% of everything that will be online, that we can consider as a kind of ultimate repository of human knowledge. In fact, 90% of everything that will be online will have been generated by artificial intelligence, which is completely insane. AI and computation has entered every single domain of what we are producing. It has also entered the issue of life. Obviously, we all know that. This is why Nicolas Negroponte, when he spoke about being digital, he said that computing is not about computers anymore, it's about living. So indeed, we want to understand computation, we need to understand in a much, in a completely new way, and also in a much more fundamental way, what are the connections between the machines and ourselves. But as we will see, in fact, I believe that in order to understand this connection between the machine and self, we need to understand a very specific feature of the computer is, in fact, it's that it's a machine which is non-psychological compared to us. I mean, we are psychological products. Humans are psychological entities, but the computers are non-psychological entities. But I will get back to this a bit later. So AI is present everywhere in practice, in the construction industry, etc. So this is, of course, on a very practical level, but we should never forget that this practical level is what fueled the research in artificial intelligence with millions or billions of dollars of funding. So we should pay attention to that. AI is also present in the domain of aesthetics and visual languages. We are lucky that Neil, as the director of this program, has published recently a book on artificial intelligence, which defends a very specific approach of what artificial intelligence could be or should in the discipline of architecture. And quite a lot of books this past year are published making a connection between artificial intelligence and architecture. So my colleagues, for example, at UCL, like Claudia Pasquero, are working on that. Daniel Bolojan also is working on these issues. I worked on these issues myself with my students at UCL Bartlett. These are works from my students from last year, all generated through artificial intelligence methods, no human intervention. But let's say, it appears to me that we still need architectural theory if we want to address all these amazing things in a new way, let's say. And this is what I want to build, because when we type in parametric design in Pinterest, for example, we have an amazing amount of answers. The answers given by Pinterest are making use of AI tools, but everything which is here on the screen has not been generated by AI. It has been generated by traditional architectural methodologies, indeed parametric methodologies. When we type in biomimetic architecture as well, we see exactly the same. Everything which is here has indeed been generated by humans. Of course, they are making use of computational tools, but ultimately it's human-generated architecture. It's just like humans augmented with computers. And in fact, this is what I'm saying. Until today, whatever its purpose, style or nature, there's one lowest common denominator for any architecture. It has always been created by humans. And this is the end. I mean, this won't exist anymore. This lowest common denominator is disappearing extremely quickly, and it will become the exception. Everything that will be generated, or let's say most of what is going to be generated in the discipline of architecture and also in some other domain, is going to be generated by machines. And this is what I'm interested in a sense. This is why I want to understand that. So just a very, very quick note on my backgrounds. I'm not new in architectural theory. I used to write quite a lot on these issues, trying to understand what are the essential characteristics of computational design, mathematics, production in the discipline of architecture. So I write extensively. I also organized an exhibition in 2007 in Marseille, which was entirely dedicated to what I call architecture beyond form, the computational term. I mean, I think this exhibition was quite essential because it really tried to create a link between what I identified as the very birth of some sort of an abstract architecture in the year 60s and what we are doing today with the help of the computer. And the symbolic starting point of this exhibition, the PhD thesis by Peter Eisenman, written in 1963 or defended in 1963. But I also believe that the architecture of Copy-Milo, for example, was an important moment, especially this project, because it was a project very much inspired by automatic writing coming from surrealism. And this project was made by blind drawings. Also, it was the very first time ever that the work of Fabio Grammadio and Matthias Köhler was presented in the exhibition, especially this brick wall. So yeah, I believe it was quite of an important moment when we talk about architecture exhibition. I kept producing and writing in a couple of books, and as you can see here, in my school in Paris, at the Paris Marquette School of Architecture, I also organized a couple of events entirely dedicated to artificial intelligence. So, I mean, I'm showing this just to show that this interest in artificial intelligence is not new to me. I'm just trying to make it more and more rigorous, more and more informed, and to give it strong theoretical basis and also strong mathematical and computational basis. So with this event here, as you can see, was artificial intelligence, the end of intelligence and architecture as we know them. This is exactly what we are experiencing today, at least according to me. And the other one was 1 year later, was robots and architecture, or the convergence of AI, robotics, and automation is reconfiguring architecture. So what I'm, doing at the moment is very much in line with this. So I theorized the shift from rationalism to computationalism. Rationalism is simply, let's say, an era which lasted 400 years, in which we put the human ratio at the very top of our scale of values, while computationalism is an era that we are entering at the very moment which is in fact putting computation at the top of all the different disciplines and all the different values we are dealing with. It's a matter of fact, on a philosophical level, some people will argue, they will say, no, the computer will never be as smart as humans or whatever. I would say it's probably true, but I always consider this as a metaphysical question. I'm a realist, and I'm interested in what happens in everyday life. And in everyday life, it turns out that everything we are doing is becoming computational. So I don't really care if, it's taking the example of religion, of God, for example. It's like, I don't really care if God exists or not. If I was to study a civilization in which 10 billion inhabitants believe in God, and this would have practical consequences on everyday life, I would be interested in these practical consequences on everyday life. I wouldn't really be interested in the ultimate question of the existence of God or not, by the way. I think it's more or less what happens today with artificial intelligence. Some debates about artificial intelligence, according to me, are not very interesting because they ask the question of AI almost in religious terms, while I want to ask the question of artificial intelligence in scientific terms. So, by the way, when we look at a computer, we know that in a computer architecture or anything else, we only have sequences of 0 and 1s. So if architecture is entirely generated by computers, then how does it really work? What are the rules? How this architecture should be defined? So answering the question is asking for a theory of computational architecture quite different from what has been proposed so far. Some are dealing with creativity and complexity, simplicity, etc., creativity and information. As I say, some theories say that creativity is information loaded, while others state that creativity is associated with deception. In fact, let's say what I want to define is a theory of artificial intelligence in architecture, which is non-psychological. What does it mean? It means that, for example, if I analyze the concept of creativity, I discover that everything which is said, everything which is written, when we speak about the concept of creativity in architecture and also in artificial intelligence, is human-based. We never consider creativity through the lens of the computer. We consider creativity through our own lenses, and we project on artificial intelligence, we project on the computer what in fact we are defining for ourselves. This is exactly what I'm interested to overcome, in a sense. And as a conclusion, I want to address the issue of computational architecture on a non-psychological basis. I want to make computational architecture theory the theory of a genuinely computational architecture, which means that I want to put myself in the position of a computer which knows nothing, absolutely nothing about the usual concept we are dealing with. For example, creativity, beauty, most of the different human approach of complexity and all of that. Because what I believe is that so far, despite its different names, it remains a theory of a merely human architecture augmented by computers. And yeah, in a sense, I want to answer the question of what the computer is really producing if I was myself another computer trying to understand the first one sending me some information. So yeah, this is what I'm interested in. Thanks a lot.
Thanks, Philippe. That was great. I just want to say that we need to kind of try and keep to the 8 minutes each in the future, just because we've got so many presentations today. But that was wonderful, Philippe. So I'd like to invite Aya to share her screen. Aya is in Dubai right now. Welcome, Aya.
Thank you, Neil. Thank you so much. Let me just share my screen. All right, thank you, everyone. It's an honor to be with you all today. I'm really happy to be here to talk a little bit about what I'm doing at the DDes program at FIU. So the title of the current title of my research is Effective Architecture, Emotive Human Systems Interaction. To kind of walk you through what I'm currently doing these days, I have to go back to my master's research back in the AA-DRL program, where I was kind of exploring different systems, multi-agent systems that have capabilities of interaction and self-assembly, and basically kind of building upon the theories by Nicholas Negroponte that he once envisioned, where basically there was a blend of physical materials and digital information within the realm of architecture that he was basically envisioning for the future, before even a lot of the current technologies were even present. So how could this lead to the possibility of this matter that create our spaces be programmed as our architecture moves more towards a materialized computational system and machine? So my research, my master's titled SlinkyBot, was basically this behavioral multi-agent system that was kind of playing on these theories of how can our spaces be embedded with some kind of information and data and sensors from the environment around and from the human, and how could they basically be representing an ever-evolving type of architecture and environment that has the capability of growing and adapting with its users. So the way it was approached is basically thinking of it on a multi-scalar level. How can this unit that had some kind of limited intelligence, how could it start communicating with other similar units, have a more collective kind of behavior, how can it interact with the human, and how can they start forming spatial aggregations. With this research, towards the end of it, actually, I started noticing that, you know, with everything that we take into consideration when we think about spatial design or architecture and all the kind of data that it was available to us, the way that the system was running basically was very limited when it comes to the information or the data that it got from the human. Basically, the system was able to recognize if the human is present or not, and also the number of occupants within the space. And that kind of led me thinking, since I finished my master's in 2017, what are the other kind of data that we can basically decode or input within a system like that from the human to create a more human-sensitive or human-centric type of design or type of spaces. So that sparked my interest into effective computing, which, although it's a relatively young but entering the age of maturity throughout the last 2 decades field, it's something that has been definitely multidisciplinary and started to find applications in automotive, in media analytics, in the medical field, as well as the design and the architecture field. So the way I kind of approached it is that we have, and from my background and the research that I was looking at in my master's, interactive architecture that is basically revolving around what kind of stimuli it can pick up, what kind of processing of this data that it can do, and how it can start responding to different environmental changes. And effective computing basically having the main goal that to create engaging, socially and emotionally intelligent computational agents that can interact with the human in a more expressive kind of multimodal way. I saw an opportunity there for these two disciplines to basically come together. The way I see it is that with human interaction, behavior, engagement, and the social experience at the core of these two specific fields, I see an interesting opportunity arising with basically collaborating these two fields together. So my main, so I believe that by bridging this gap between the pure material research and architectural systems and effective computing technologies that can interface with human emotions and affect, this could yield to innovative approaches to design that address critical psychosocial issues related to our affective states, perception of ourselves and of our environment, as well as social interaction with one another. So it's trying to help us re-examine the relationship we have with the spaces that we occupy, as well as with one another. So my attempt is to get to a point where interactive systems move beyond considering the humans as mere physical boundaries and looking at them as emotive behavioral beings, which I would hope that would result to a more sensitive machine-human interaction and profound experiences within the responsive environments. So the main objective of my DDes is to develop this relationship between materials, form, behavior, interactive systems, to generate this empathetic relationship between humans and their environment, to explore the potential of how simulated affect recognition could blur and generation could blur the harsh boundaries between machine-human ecologies and develop a state of harmonious coexistence and companionship, as well as address psychosocial aspects in human-to-human interaction through the mediation of design systems. So again, the way I see it is, especially with effective computing, kind of realizing our current day dependence on technology and computer and interfacing with computer and machines in almost every aspect of our daily life. I saw the way I kind of see interactive architecture as they are moving towards being basically architectural machines and computational systems. I see that our spaces will become literally the largest machine-human interface, which is why I feel there is a necessity to have these systems be more sensitive to the human affect and to the human emotional states, or have at least some sort of not just an artificial intelligence, but some sort of an emotive one and some kind of emotional intelligence that could basically lead to a more human-centric design system. So my research questions basically are divided as such, which is first defining what is effective architecture and design, and then what comprises an interactive design system that could be said is affect-driven. And the most important one, which is basically like the main body of my research, is what is this framework for an integrated, effective architectural design system that can foster this effective loop between the user and the environment? And in terms of a more application kind of question, what are the ways that we can utilize these effective computing technologies to contribute to the development of these design systems that are And in what way would we basically apply these design systems to create our affect sensitive, responsive environments? And finally, basically, which is focusing on the impact of this all, how can effective design or architecture influence our social interactions and the experience of spaces? So the way that I was thinking of tackling this, these research problems or questions is through a methodology of obviously a literature review, and also through a more design-based kind of type of research. With the literature review, looking obviously into the history and the theoretical underpinnings of affective computing, as well as interactive design, and looking into the ways that have been developed in terms of affect recognition, affect generation, and the databases and the methodologies that make and the algorithms that basically map these emotive cues into computational data that we can analyze and make sense of. And finally, looking at some of the emergent applications in design and architecture that have attempted to utilize affective computing as well. So it's important to look at the history and the theoretical underpinnings of affective computing when basically dealing with the research problems that I'm interested in exploring, and looking at the different emotional theories from various psychological, neuroscientific, physiological, cognitive, and computer science perspectives. One of the most important books about this, I would say, is by Rosalind Picard, who coined the term affective computing at MIT in 1997, and wrote this book in 1997. And I would say that in my research and readings of these different theories, there is a certain consensus that that emotions is something that can no longer be ignored, which is something that have been, I would argue, that has been overlooked by the scientific community, for some time. And that emotions is something that can directly influence cognition and other responses, including perception, attention, motivation, and decision-making capabilities, since it assigns a certain layer of value system that prioritizes different decisions over other. So a lot of...
we need to wrap up fairly soon. If you could just try and wrap things up. Thank you.
All right. Okay. I'm sorry. I didn't know I took that much time already. So I think I would like to a little bit emphasize on the design-based research aspect of my DDes, which I, again, drawing from some of the lessons learned from my master's research, I'm trying to develop a system, an interactive system that can integrate this affective loop where recognition, analysis, and certain response triggers can be fed back into this interactive design system in the form of a simulation as well as a physical prototype. Recently, I've connected with a company called iMotions, which I will be able to have access to their technologies. Basically, iMotions is this software developer that have basically partnered with a lot of the leading biosensor companies, manufacturing companies, to basically specifically for affect recognition. So the way the software basically operates is that it has the capability of integrating multimodal affect technologies and recognition in basically in a one single platform, which is something that I think is essential, since when it comes to affect recognition, I would say that depending on just a single aspect or a single sensor or a single mode of affect recognition would not really yield to a to a more contextualized and a more, let's say, developed input, but definitely a multimodal way is definitely more, let's say, dependable. So, I mean, I don't know, I'm running out of time, but basically, the ways that the different modes of affect recognition can be in terms of facial expression analysis, or eye tracking and eye gaze, or through basically brain activity and EEG data, or ECG. The one that I want to initially focus on, but I do intend to integrate with other modes as well, is the facial expression recognition, mainly because of its non-intrusive way, and the way I kind of see these systems operating is in again, like a spatial application where the human is kind of free to roam around. So with facial expression.
So we need to wrap up really very quickly.
Okay.
So if you could just...
All right. I'm in my last couple of slides. So as I mentioned, the main aim of this research is to basically find ways to kind of integrate this affective loop within the interactive design process, and mainly focusing on setting up a framework for architects and designers to integrate effective computing technologies within their interactive systems. So I see this as the main kind of contribution to the research. Yeah, that's basically it. Thank you so much.
Thanks, Aya. Let's move quickly on to Matt Gorbet. Let's try and keep to 8 minutes. I know it's difficult, but so we started off in Shenzhen, we went to Paris, and then we went to Dubai, and now we're in the northern climes of Canada. Matt, well, welcome.
Thank you very much, Neil. I'm very happy to be here and share just a little tiny bit about my research direction, where I'm coming from and where I'm going. I'm assuming everyone can see my screen. If not, you'll let me know. As Neil mentioned earlier, I did do my master's degree at the MIT Media Laboratory in the Tangible Media Group, exploring the connection between physical spaces and information, and can we create new ways of bringing information into the physical world. And after that, spent some time at Xerox PARC, the Palo Alto Research Center. Now, this was a couple of decades ago, so this is a while back. And in between those times, I spent a lot of time thinking about what happens when we start to bring information into the physical space, and building both experimental and also commercial installations that try to blur the boundaries a little bit and create new experiences for people using technology. So that's been an interest and a passion of mine for many, many years, in bringing this idea of surfaces and the built environment being able to express itself poetically and dynamically and in response to the actions of people. So it's not a new thing. This is something, of course, in interactive architecture, soft architecture machines, Warren Brody, Negroponte, these questions of how can we live in, how do we think about living in a space that can come to life, or that can in some way express itself dynamically? How do we conceive of having the spaces around us recognize us and respond to us? This has been something people have been thinking about for a long time, obviously, but I think the thing is we're at an inflection point right now where new material technologies, soft robotics, color changing, shape changing, alloys, metals, materials, manufacturing technologies are starting to actually make this real. And I think what's going to happen is we're going to be in a situation very soon where we have the capabilities and the capacities to create these kinds of new matter within our built environment, both architectural and industrial design, with embedded electronics, with pneumatics, all these different things that we're starting to see come up from all over the place. And the question is going to be, how do we work with that? How do we as designers, as design students, as architects start to work in that way? So flash forward to 2018, and since then I've been working with a group called the Living Architecture Systems Group out of Toronto, but global. It's a global consortium of people who are from all different disciplines, who are investigating this question of, can architecture integrate living functions in some way? Can it become a system that has metabolism, a system that has affect, a system that can have empathy to its occupants. And this is a bigger research project. It has a lot to do with the way architecture is considered and the built environment is conceived and also fabricated. But at the same time, deep within that, there's an aspect of it that is about the control systems or the guidance systems or the feedback systems of these installations. The working method of the Living Architecture Systems Group is a research creation method. So we conceive of and install these spaces, these installations that we consider as test beds, where they're created and installed in public spaces for the public to operate with. And within that space, we can think about how we do create this space. How do we think about the components, the architectural components, and also the software and the hardware that drives these systems? So that's been my focus, has been creating the underlying software, the systems, thinking about how do we bring them to life, and essentially how do we think about that human and architectural relationship from a technical perspective. How can we create systems that enable the design of compelling and impactful experiences driven by the built environment and experienced by real humans? So this is the methodology, and this is the basis of my DDes work. It's been ongoing, but what I'm really trying to do in thinking about both the technical but also the logical is to go back to this idea of how do we make these kinds of experiences accessible to designers who are not necessarily technical, who are not necessarily building everything from the ground up, but broaden the reach of this kind of thinking around the built environment by creating tools and tool sets. Now, in order to create tools that make this kind of design accessible, I think what we need to do is to actually think about the underlying structures that enable the architectural components or the pieces that are going to be part of these systems, whether they look like this, whether they are parts of the sort of Living Architecture System Group aesthetic and form language, or whether they draw from other, maybe even more traditional aspects of smart matter or ambient, software robotics, distributed computing. So the kinds of work that I'm involved in is in looking at these test beds, in building these systems, and in creating the tools to try to imbue them with new kind of algorithms or new kind of ways of responding to their occupants, or ways of expressing themselves that are driven, that are accessible, I should say, to designers who are not directly necessarily involved in all of the nuts and bolts of the physics of these systems. So, for example, this is an image of how we took a control system and we turned it into a distributed system where we took the algorithms that we were using to control the system and distributed them within and among the nodes that created this environment. By doing so, we were able to create synchronized and collaborative or connected choreographed behavior among nodes that were completely independent. And this has huge implications for the scalability of this kind of system. It has huge implications for how we think about communicating with the system and connecting it into other systems that are heterogeneous, that are being developed by other people, so that this kind of demonstration or this kind of environment doesn't become stuck as a lab demo or an art installation, but instead has the opportunity to be used in a sort of test bed fashion by others, other designers, design students, other architects. And the output of my thesis and the output of my research is trying to be a set of principles, perhaps, and a report on how we're thinking about the underlying structures at a code level, at a software level, that are going to enable this kind of connection to other research that's going on, so that these questions can be explored. Another aspect of what we're doing, just as a quick demonstration, is thinking about the boundary between the physical and the virtual. In the same way, if you start thinking about this distribution into the built environment, you can also start thinking about the crossing of the boundary between what is actually in front of you and what is represented or what is created digitally or what is virtual. There's a lot of work in AR and VR, et cetera. But what we're trying to do is think about the underlying systems that drive these kinds of work, with digital shadows, with living systems, with projection mapping, all being incorporated as part of a cohesive underlying software system that can then be used to design for new materials, but also the expression of what those new materials could bring in terms of demos, prototypes, and instances of the vision of architects. So this is the pavilion that was done for the Venice Biennale last year, and it also explored this question of the intersection between the physical and the virtual with a dynamic pool that was working with computer-generated graphics that took elements and aspects of the surrounding installation, both physical and auditory, and moved them into a space that could be seen, interacted with, and moved on. That is projected into a pool. So this question of making it not matter whether these things are actual physical in the space or virtual or a combination of both is part of this breaking apart of how do we think about the dynamic environment that surrounds us? How do we think about the built environment in new ways? At the core of this is really about education. It's about rethinking the way design is done, and including, in addition to the typical, color, materials, form finding for industrial designers, for architects who may not be technical, how do they think? How should they think? How can they think about time, behavior, and interaction as part of the material palette that we're all going to be able to work with very shortly if what's happening in labs right now does come to bear? And it looks like it will. We'll be creating different kinds of experiences, different kinds of built environment. We'll have the opportunity and the ability to surround people as architects and as designers with new and possibly society-changing ways of thinking about our built environment, and possibly addressing the way we live together, the way we think about the longevity and the flexibility and the dynamics of the spaces that surround us. So that's my exploration in the DDes program at FIU, and I'm happy to be continuing it, and I'll be happy to follow up with anyone who wants to continue the conversation. Thank you.
Thanks, Matt. It's always so inspiring to see the work that you've been doing up there with Philip, from Philip Beasley. Now we moved from the colder climes of Canada down to Miami, to the warmth of Miami. Felice Grodano, actually, in some ways, you two guys both Matt was studying at the MIT Media Lab, and Felice was studying just down the road at the GSD. But anyway, Felice, welcome.
Thank you, Neil. It's great to be here. Let me just set this up. Can everybody see my screen?
Yes.
I'll assume that's yes. Fine. Just stop for a second.
Just say, please try and keep to 8 minutes, Felice, if you can. I know it's challenging, but we have a lot to get through yet.
Yeah, I'm having problems. Let me try one more time. Okay. Let me try to maximize it. If not, I'll do it in this configuration. My apologies. Okay. Just a little bit about me, as Neil said in the beginning. Actually, even though my background's architecture, I've been practicing mostly as an artist, especially down in Miami. And about 2017, I was invited by the Perez Art Museum in Miami to do basically an AR, augmented reality only exhibition. And I was able at that time to really get into the technology, which I hadn't up until that point. And we did actually a few really large scale immersive installations. And so obviously it was a crash course for me. This was 2017. And the thing I found about technology was, of course, augmented reality allows you to, in fact, augment a kind of visual and immersive experience, but also the kind of evolution of just the way things look and feel as an artist when you actually practice in this manner was something that was quite new to me. So, when you look at these slides, I'll just go back and forth for a minute. It's very obvious that it's art, at least to me, that, the aesthetics are such where the user, the experiencer coming to the museum at that time had a kind of expectation that they would be looking at artwork. Now, if I skip to an experience that kind of pivoted me away from that in a certain regard, this is obviously just a digital model. And there's no world, there's no kind of context here except for its shadow. But I actually took this object and I projected it one day, just walking around the beaches of Miami. And I had a very different reception to this artwork than I did at the museum, which was that I didn't really give it away in the sense that it was augmented reality. And in fact, someone was fooled. So I received this comment that said, "Where is this?" And I said another world, because in fact, it just gave me a moment of pause because I wasn't quite sure really where it was, where I was. So I began to think about this kind of conflation between realities. And I just took it a step further in another work of mine. This was a work I did, which is pretty standard for all of you architects. You do a 3D model and you kind of explore it and you fabricate something maybe as a result of that. And so this was a sculpture I did that was housed at a site. It's got a position, a location, it's anchored permanently. And then I did an AR version of that same artwork. So this is just a walkthrough of the analog and then a walkthrough of the AR version. So what was happening with this new body of work is that I was kind of testing a kind of verisimilitude to the original. But obviously, it's kind of a simplistic example of what I would call a kind of digital double. So this was something that became very interesting to me, and especially something that was explored within the beginning of my DDes program. And so I began to think about this idea of doubling. And ironically, we happened to see this amazing lecture by Benjamin Bratton in Digital Futures, and he kind of touched upon that. There were larger questions about augmentation and simulation within this lecture he gave. But for me, this was a very interesting strand of theory that I was really interested in pursuing. And specifically, do reality-based technologies merely duplicate analog reality? And what about power and control? In other words, where does the agency lie between these realities, or one reality versus another reality? So these were things that kind of got me really going within the program. And so I decided to focus on these types of questions. So for example, when I say reality-based technologies, just to define what I'm thinking here, right now I'm defining that as AR, VR, and MR. And what about it? So what I'm claiming basically is, although considered emergent and novel, in many ways, the deployment and creation through reality-based technologies are still very much entangled with the control mechanisms of the analog world. So this is a claim I'm making. And so in turn, due to the newness of these technologies, I claim there's a current void actually in discourse, and one that critically frames the often undermining of so-called freedom in such spatial practices. And two, I'd like to explore areas within them for possible agency and emancipation against such hegemonies. Now, when I say hegemonies, excuse me, I'm basically defining it in the classical way of the kind of dominance of one group over another. So this could be primarily seen by way of economic dominance, political dominance, or even in some cases, military dominance. So what's my goal? Well, my goal is to expand upon those points as I outline them. And why? Because I argue the development of reality-based technologies impacts the definition of reality itself, and that these realities affect one another, often for better or for worse. So some of the background information, I'll just be very brief about this. If we look at a kind of more classic idea of media and medium, for example, in architecture with digital renderings, digital renderings can be construed in fact, as control mechanisms. So the kind of classic concept of the kind of before bad, after good approach is often systemically coming from a sort of point of view of redevelopment and displacement. So I would argue that this kind of medium is often a top-down medium, and that there's really no mediation of the viewer within it. It's really about a kind of convincing motif than a kind of participatory motif. And I think that's very different with reality-based technologies, because in reality-based technologies, and this is my claim, that because there's a kind of decoupling from an original source in the form of, say, a digital double, twin, or shadow, that within these respective realities, there's kind of a paralleling going on. And so because of that, I think it's both what I would call a hot and cool medium as defined by McLuhan. In other words, mediation is possible. So, and these are just some elaborations of the kind of classic definitions of what a digital double twin in shadow is. Often we kind of play with these terms, Bratton does with regard to a kind of metaphysics, but these are very specific technologies. They're obviously being developed and have been developed. But what it really leaves you with is this kind of interesting, I think, ability to kind of traverse realities. So what does that have to do with reality? Well, if there is no ontological truth to a reality, then there are parallel realities, so that there is agency in and of itself within each respective reality. So this is, of course, a claim that I'm making, which, you know, I've been kind of going down the rabbit hole within my own research, but this is something that one has to buy into as far as the way I'm going to pursue this. So what about power? Well, if there are parallel realities, what are the ramifications between exporting and importing via digital doubles, twins, and shadows? So between realities, or using these motifs and mechanisms, what are these ramifications? And also, to my point, are these kind of modalities just simply maintaining a kind of hegemonic status? Or is there actually a kind of moment or space for an emancipatory exchange or movement or politic? Now, one way that I guess one can maybe start to think about this is really through a kind of analysis or kind of case study. Even though this is a relatively new phenomenon, there is enough out there to maybe start to explore moments that this occurs. So that's really what I'd like to do through my instrumentation, the kind of way I want to approach this discourse, is kind of begin to use a kind of pairing of doubles, twins, and shadows within comparative case studies. So I created this rubric, and within this rubric, which of course could extend or be more developed, right now it's kind of very, very straightforward, where there's a kind of assignment that I would give to each pair. So is this pair a pair complicit? And is it unintended? Is it complicit and intended? Is it non-complicit and unintended? And is it non-complicit and intended? And what I mean by that is there a hegemonic status, or is there an emancipatory space? Now, let me give you some examples, and I'm going to try to do this quickly, just to illustrate this rubric. So, for example, I would call this a complicit and intended sort of pair. So if you think about this in a more simplistic manner as a kind of digital double, this is a meta-real mansion in where the kind of metaversian residence is developed really in the same kind of parallel domain as the analog. So it's kind of, normally we would think, okay, well, this house would be designed, we'll then put it in the metaverse, but actually these are on equal grounds. So of course the house is being minted and sold via NFT by Sotheby's, which is actually a quite respectable outfit as far as art and real estate. So for me, I call this complicit. Why? Because it kind of upholds, in my opinion, the kind of ascetification of architecture. This I would call complicit and unintended. Now, to the left, for those of you who know your history, this is actually a collage by Super Studio that was actually done in 1969 to 70, part of a series called The Continuous Monument. And in fact, it was a critique. And to the right, which is actually a current digital rendering, it's a project in Saudi Arabia called NEOM. And this is actually one development within that mega project called The Line. And in fact, this project is under construction. So what was actually meant as a dystopian critique many, many years ago is now being implemented as a very kind of strong representation, I would say, of Saudi Arabia itself. Now, a more updated version of this would be the fact that NEOM is actually borrowing metaversian architectures within the storyboarding of this project. So I would say this is actually complicit and intended. So there's a kind of export of the metaverse now into analog reality that becomes a kind of I say kind of streamlining of fantasy through a kind of powered appropriation. Now, a non-complicit and intended, and I would say emancipatory, perhaps opening within this, is something that actually just occurred in November. Tuvalu is actually a small island in the Pacific Sea. It's I don't even think it's actually occupied with people, but it is considered a sovereign property. And basically to the left, you can see this image of the kind of representative of the state kind of making a pronouncement that because of sea level rise, that the island in fact will go under, that it will be subsumed within the water, the ocean. So he's making a kind of pronouncement as such, because what he says is the only way to preserve the island is actually through a metaverse version. So that this video actually pulls back to then reveal to the right a metaverse kind of image of the island itself. So it's very Solaris in a way, but I find the moment quite powerful. And I would say this is also a non-complicit and intended and a kind of emancipatory usage of this of reality-based technology, where to the left, you may be familiar with Jeff Koons's work. In 2017, he teamed up with Snapchat, the app Snapchat, and they actually teamed up to deposit and geotag some of his works. This one's in Central Park, for example. And to the right is artist Sebastian Arasiris, who basically hacked the project and took Balloon Dog and graffitied it. And his, and more interesting actually than just the visual, is that he created an open source app called ARNYC that basically had no advertising, no data tracking, and so forth. And his whole point was not just the kind of digital tracking, but the actual analog territorialization of land in the city was something to be aware of with regard to these technologies. Now, in conclusion, what is my goal? Well, my goal, it is a humanities-based project, but my goal is to create a qualitative research methodology by incorporating a critical discourse analysis that utilizes multimodal content, specifically social cultural analysis implemented through these case studies that deal with importation and exportation. And as far as the limitations, you know, basically, if you look to the far left, if you believe that reality-based technologies are simply simulations, then I guess my dissertation is invalid. But if you go towards the kind of gradients of reality that I'm kind of constituting here, the far right is where I'm at, which is that, again, I put these along the kind of lateral level of parallel realities, which I think affords a kind of leveraging, if you would. And what are the implications? Finally, you know, I do believe a critical discourse that addresses the hegemony of reality-based technologies is required at this time. And obviously, what I'm interested in is the emergence of possible emancipatory strategies and tactics, not just by way of my own research, but by others. And of course, you know, I believe that breaking or reversing these kind of control mechanisms by leveraging reality-based technologies are important because they affect realities, and that's what is at stake, in my opinion. So, thank you very much for allowing me to participate.
Please, thank you so much. Now we're moving to Barak Chama, who is someone who's also very international, originally from Israel. He's actually in Tel Aviv right now, but he's been working in New York as an adjunct professor at NYU, and also in Japan for Team Lab and other people, and also spent some time in Singapore. Barak, it's great to see you. Welcome.
Thank you very much, Neil. Just 1 second, I'll share my screen. Right, is this coming through?
Yes.
Yes. All right. Well, thank you for having me. I'm Barak. My sort of exploration as it's forming through the first semester of the DDes program is a focus on cross-domain adaptation, working with multiple types of systems, multiple systems across different boundaries and how they operate together, beginning with a focus on urban food systems, and trying to achieve an interface for cross-system collaboration or extension. A little bit about me, as Neil mentioned, I graduated from NYU's Interactive Telecommunications program, ITP. I'm not an architect. I come from software engineering, creative technology, and media art. I taught at the Integrated Digital Media program at NYU, IDM, and is now faculty at SVA's Interaction Design program, IXD. I'm also a co-founder of Strata, which is a distributed digital gallery, sort of headquartered in Tokyo, but operating all around the world. My experience with systems starts from my background as a software engineer that expanded after I graduated from ITP into creative technology and media art. And even though I'm not an architect, working closely with architects through larger scale projects like ones with TeamLab, where architects are embedded in the team because of the scale that the work reaches, or with projects like Rockwell Architects, where an architecture firm is entering the world of interactive spaces and interactive content and working with people like myself, creative technologists and media artists, to understand how the physical and the digital combine in new ways to create immersive spaces. Also work for another studio based in New York called Cactus. My personal practice is more of a sort of socially oriented, multidisciplinary media art practice where I approach systems in a different way, trying to understand the way that technology interacts with social life, personal life, cultural life through deep dives into social media, automation and production, surveillance through video and kinetic installations. And that is sort of my own artistic practice. But the interest in understanding how technology integrates with or interacts with other fields of lives and how the two evolve and influence each other led me to Digital Futures and then to the DDes program. My focus coming into the program was very much focused on understanding or exploring the opportunities in the interaction between food systems and urban systems. Food systems, because they sit at a very interesting point of being a key source of human or anthropogenic climate change, a driver of climate change, but also one of the human activities that are most at risk, both in terms of changes to land and in danger to our human scale food supply, but also urban systems, the growing population and urbanization trends all around the world, and how they too coincide to offer a very critical point of leverage, but also of influence on climate change, sustainability action, specifically as it relates to architecture. One of the key problems in understanding food system action, food system transformation, but also urban transition is one of maladaptation, one that even this year, the UN and the IPCC, the Intergovernmental Panel on Climate Change, the European Union, risk that are one of the sort of key dangers to successful coping with climate change. Maladaptation, either in inaction or taking wrong action that is misinformed, underinformed, and is even as action is taken, proves to be action that sometimes doesn't have the necessary or desired result, or even taking us back in the wrong direction. To address this challenge of food systems and climate and in urban transition, a lot of the times system-based practices are deployed. And this comes from a realization that both food and cities and climate are all wicked problems. They are problems that have significant time delays in trying to find a solution, but there's no central authority dedicated to finding a solution. Those that are seeking a solution are sometimes also the ones causing it, and different motivations, different priorities, and different policies irrationally put different actors at odds with each other. So addressing these problems requires a systems-based approach, and that's something that's widely accepted across different sort of disciplinary circles, and yet we are still dealing with issues of maladaptations in the space. To briefly illustrate the problem, I think we can, this is an example that I think is really, really telling, is looking, for example, at corn subsidies in the United States, and how looking at the different disciplines or drawing the boundary of priorities in areas of concern, whether it's an economic concern, an environmental concern, a health concern, a food culture concern, can lead to different determinations of whether or not corn subsidies are beneficial, detrimental, how to move forward, whether we're moving forwards or backwards. And we can see that at the same time that subsidies expand, there is critique both on environmental impact and health impact in the US and internationally. So the goal of the project is to try and understand systems, to try and explore frameworks and tools for open collaborative system design in addressing the complex cross-domain challenges of urban food sustainability, and hopefully come up with solutions that really focus on open collaborative systems that can be applied in other domains. Looking briefly at the issues of food systems in the city and urban areas in particular, I'd like to offer a systems-based perspective to look at what we'll be briefly discussing, and that is thinking about systems as a collection of stocks or actors that engage in a process within a boundary, and the boundary is really key here. What do we decide that is within a system or without it? Within meaning that we are accountable for it, we quantify it, we can affect it. And the environment is something that is external, whether we even acknowledge that something is external and we have an impact on the environment, but we can't interact with it, or we can't intervene in it, or whether we don't even acknowledge the environment at all, which is a frequent issue. The definition of a food system, even in general, is already a point of contention. Different organizations provide different explanations and different definitions to what the food system even is, whether it's only food, whether it's food and society and economy, and the environment and culture. And these are different boundaries. We put the circle around different constellations of factors and how they relate or don't relate to one another. Another key problem in sort of systems perspective on the way that the food system is mapped is the issue of scope versus resolution. How wide is our net when we try to map every single process that touches the food system? And how deep do we dive into each of these processes and map them out? And that has to do with how broad of a perspective do we have on the system on the one hand, but how operational or comprehensible it is on the other. If we look at the two maps on the right, we can see that the top one is very broad, speaks in general terms, but very understandable. The one on the bottom tries to map every single process, but if you're a layman trying to understand what the hell is going on, it's very hard to find a point of intervention with all of these twisting and interconnected arrows, both theoretically and visually. Same thing applies to trying to map out the city, particularly in studies of urban metabolism. The other issue is, where do we draw the boundary? As we mentioned, this causes serious problems because even studies that operate on the same question, trying to understand the same question, can draw different boundaries that will result in completely different understandings of the factors that are at play and completely different conclusions, policy recommendations, and actions in the end. This is a key source of maladaptation and action in the wrong direction. These are three examples of looking at food systems from a justice perspective, from a local sustainability perspective, and from a policy perspective. So clearly, if we're looking at these sort of dotted lines that sometimes overlap because they all touch food, but they don't interact, they don't interchange, and they don't expand on each other. The same is also true, again, for mapping out cities. Finally, there are efforts, and it's important to acknowledge this, there are efforts at cross-system mapping, but often what they do is, say, with the examples again on the right, trying to mitigate the socioeconomic system with the earth system, or trying to bridge agricultural production, resource use, and food security systems. They choose a key variable, a key element, a key actor that is used as an interface, and really what you result, the outcome of this process is not so much an open interface, but just a broader system that is still enclosed. I think this is very telling in the visualization on the bottom right, where there are external stressors, and what the connection to these external stressors, who knows? The system on the top doesn't even acknowledge anything beyond the socioeconomic / earth system. So we're extending the problem, but we're not really resolving it. So sort of to summarize, some of the issues with systems that I've identified, that others have identified with the way that theoretical multidisciplinary systems are mapped, are inconsistent definitions of the boundary itself, system variance in terms of resolution, geographic focus, disciplinary focus. As we've seen, we can have a focus that's on policy or justice or sustainability, and they're not often compatible with each other. closed system design that often doesn't acknowledge at all or acknowledge very loosely some kind of environment, but not how the system interacts with it. And the risk of maladaptation that is a result of all these. We can have systems that are poorly designed or designed with a specific bias or skew in terms of focus and context, and they're not easily expandable, they're not easy to evaluate as to their completeness. This becomes even more of a problem when these are then translated into operational frameworks where the system is sort of obfuscated or obscured. So the goal of the study at a theoretical level is to propose a framework or a methodology for system design that goes from increasing systems but closed boundaries to a more porous open system design methodology that allows for collaboration and extension and integration. And the goal of this is so that systems connect with one another and an emergent metasystem becomes possible to both observe and assess and analyze and expand. So every system contributes to the other. As a software engineer, to me, this is really natural. I'll give the really brief example that I gave in the review of our projects for this semester. And that is, if you want to build a food delivery app, say, in today's internet, you really can't build anything on your own. You need to integrate with social networks and databases and authentication services and payment mechanisms. And these are all systems. They're technical systems, and they're designed for integration. They're designed for other systems to communicate and extend them. That's how the internet emerges. The internet is not controlled by any one single entity, but it emerges and becomes enriched from the more systems engage with one another. The beauty of this kind of approach is that if you are, as a food delivery service, decide to open your services to other systems to integrate, you become one of these connectors. You become another node that other systems can connect to. And that's how the internet grows. Looking back at the urban level, or at the inspiration, I'd say, for what I'm trying to achieve in terms of system design at the city level, albeit with a focus on food, came from inspiration in conversations in classes. And I want to share some of these because it's still more of an ongoing process of defining what the goals of the study actually are. But it has to do with public transport, really with how public transportation is mapped in the city, and some of the insights from observing the different responses to system challenges or systemic challenges in both the design and operation of a system. So the first has to do with, so this is all different maps of the underground, focusing on London, but also in other cities. The first has to do with mappings that respond well to resolution. How does for example, the London Underground resolve the scope versus resolution conflict or challenge, or mutual exclusion, you could say. And that is by offering maps that focus on a specific context. You can see on the left, a map of the entire underground that in itself already abstracts the map on the right of what the central line actually traces through the city to become a mostly straight line that relates the city of London in as so far as it interacts with other lines. So you can get from the northeast to the southwest, but the actual terrain that the train goes through is abstracted because it doesn't matter. What matters is which station you get in and which station you get out. There's another level of abstraction we can see in the top is the view that you see when you're actually in the train. And that view, the curves of the central line don't even matter. What matters is which station you're on and which station you're going to. And these can be plotted on a straight line that also easily fits inside the train carriage. So different maps or different map representations borrow well to different levels of focus and resolution, and they adapt to the specific context that a commuter or a user will have to then experience them. Another key key insight is this idea of system interchanges or system interfaces. A really good example of this is the MTA, the Transit Authority of New York and New Jersey, that operates multiple systems of trains. There's the New York subway, the underground. There's the Metro North that goes from New York City upstate. And there's the Long Island Railroad that stretches east through Long Island. And they all interact with each other. You can ride the Long Island Railroad and enter the New York subway. You can start somewhere in Brooklyn and go to Manhattan and board a train to the Metro North to go to Spring Valley or Albany. And not only are these systems, in terms of the way that the station is built, they interact with each other, the way that the systems are mapped, both share in a common syntax. So this is a key, a common syntax of how the maps are formed. the subway is colorful, but the others are not, but they're very easily recognizable as sharing in the same visual syntax and topology. And the other is clearly demarcated points of interface. And you can see that in all these three maps, there are these larger white circles that denote cross-system interfaces. So even on the New York subway, where there's smaller lines that mark in-system transitions between lines, the bigger circles that are the same size and the same shape across all the maps denote cross-system interfaces. This allows you to hop from one system to the next and treat the entirety of the New York subway and the Metro North and the Long Island Railroad as one expanded sort of meta system, one that has clear interfaces between one and another. The other thing that I think, again, is really interesting is the fact that the success of the London Underground or the London Tube map with a simplified view of how the trains stretch through the city was successful and was embraced by other cities around the world. Now, this is not only beneficial to show that a good topology of a system really is, when it succeeds, it sort of it gets a life of its own and is expanded. These are just examples of cities that I had the good fortune to live in for a while, and these include London and Berlin and New York and Tokyo, and they're immediately recognizable as a commuter. You arrive in a new city and you know how to find your bearings, almost like you're a local, because all the maps look the same. But if we think about it again from a system interface perspective, it means that there's an emergent meta system almost that connects all of these cities through interfaces that are either explicit, as we've seen with the New York subway, or ones that are implicit by the way that the system is designed, by the way that actors hop from one to the next and are able to traverse through multiple geographic regions, through multiple transit providers. The last point has to do with interactivity and with how interactive tools, the specific here is Google Maps, but any interactive map is able to resolve the challenges that we've addressed in the first sort of subway slide, when we've seen different map topologies that borrow well to different levels of focus, but all within the same screen, all within the same user experience. When we start from a very high level zoom, we only see main roads. When we zoom a little bit further in, we start to see the main roads labels, then local roads, then local points of interest, then where the subway stations are, all the way down to the actual street addresses by the numbers. And that has to do with showing the relevant information at every level of focus, but that is all part of one continuous experience. So there's a gesture that zooms in and out, and there's a mapping between level of focus and the actual zooms from the Google Maps API, and what is appropriate to show at this level of focus. And when we think about system design at a more theoretical level, say we're mapping food systems or urban transition, urban metabolism, how do we integrate at a formal level interactivity as a tool for resolving different levels of resolution without losing data? So again, go back to the example of Google Maps. I can zoom in and see more data, and I zoom out and that information is gone, but it's not lost. It's maintained in different levels of resolution of the system. Finally, and this is just a quick aside from an exercise I had with my students last year that focused on the user experience of riding on the New York subway, important to remember that even successful maps leave something behind. There's always something that is beyond the boundary, that is left as an externality to the way that we map the system, and that's inevitable, especially with something as big as the food system that touches economic and environmental and social factors. And how do we design a methodology for mapping systems in a way that opens points of extension for someone else to pick up the task of extending the rest, as I mentioned, trying to achieve an emergent quality in system design rather than trying to achieve an entire fully comprehensive focus with one study or with one research or one tool. So again, the goal or the focus of the research is a framework for open, meaning extensible, collaborative, meaning multidisciplinary, and interactive, meaning accessible design of systems. In terms of goals, what that means to me as I pursue sort of the task of both finding inspiration in other systems and trying to formalize them into a process is figuring out how to map interfaces and interchanges at it's sort of both a theoretical and a visual level, at a tooling level, devising a common syntax that makes it possible for someone looking at food, say from nutrition or from a policy or from an economic perspective, to share a common language as they evaluate each other's systems and integrate them, whether it's different processes, different actors, different resources, and how they are reconciled. Emergent metasystems, as I've described, not trying to map everything out at once, but opening up a system to collaboration in the same way that papers are cited, say a system could be cited or expanded, much like how the internet works, as we described very briefly, in trying to formalize interactivity as a tool that addresses the challenges of resolution versus scope. Some of the sort of directions that I hope that the research will evolve in is one in second order study of systems, particularly second order cybernetics, but also borrowing on other ideas in systems theories, complexity theory and systems thinking to formalize this system of systems, this methodology for system design, the idea of common resources, very much inspired by GIS, but at the actor level rather than at the sort of geographic level, at the theoretical level of a specific actor or node or multi-resource, you could say. How do we go from talking about food to talking about calories to talking about emissions in a way that can open up a conversations to a diverse set of actors and stakeholders, and also hopefully a resulting common mapping topology for systems from diverse disciplines. And finally, a research of interactive tools. This is where hopefully, again, as a software engineer, I'll be able to propose some maybe prototypes or modalities for how these systems can be both designed and then explored or operationalized. Thank you.
Thanks, Barak. That was amazing. I just want to take the opportunity as we move on to our next speaker to thank Gray Reed, who has been on Barak's committee. Gray is central to the DDes and has been is the chair of a number of candidates. She's her background is a history and theory, but with a particular interest on environmental design questions and sustainability. Also, I would like to mention Shaheen Vasik, who is also central to everything. Shaheen is an engineer by training, an architect engineer. She has been responsible. She is the force behind the RDF lab that has been so significant in the school, and also has been responsible for getting an extraordinary number of NSF grants as part of the CREST Foundation, and has been an important part of the team. And there are others involved as well. We'll maybe mention at the very end. But can we just move on quickly to Leela, who has been working with Shaheen on an NSF CREST grant. Leela is also a very international figure. Welcome, Leela. We can't hear, Leela. You're muted, Leela. You're muted.
Okay. Can you hear me now?
Yes.
Okay. Hi, everybody. So I would like to quickly present my DDes research proposal. I'm at the first year FIU, and I'm a CREST fellow, which is part of a new collaboration between School of Architecture and a Center for Aquatic Chemistry and Environment. So it's a joint effort between designer and environmentalist or scientist. Quickly talking about myself, I'm a material researcher. I'm a founder of a material library and a material focused makerspace, and also a cafe and shop that sells material and series of products made of new materials. My work has been expanding from artwork all the way to the scale of architecture. And I would like to design material focused experience, material fabrication, new type of building material, and also commercial projects that utilize materials, sustainable materials specifically. So for my DDes thesis, my research focus has been surrounding on coastal resilience. So I think I don't need to educate everyone about sea level rise and the problems surrounding about sea level rise, especially when I moved from California to Florida. I physically experienced 2 hurricanes, and it made me realize the seriousness of the problem. So in I think 60 years, 70 years, Miami, according to scientists, will be underwater completely. And currently, I would say the solution surrounding coastal resilience has been greatly about engineering. So historically, gray coastal structure like seawalls has been built to defend our coastline. And this measure were effective until in the recent year when there are more storminess or more hurricane. This type of static or monolithic structure is causing more trouble than helping our situation. So this coastal resilience is actually a new idea, because in the past we would say coastal construction or coastal sustainability related terms. So resilience is the new term that I would say ecologists or urban planners or policymakers actually use to describe this new center of study. So this problem actually involves a lot of, it's a complex map of different studies like scientists, urban planners, architects, material scientists, marine ecologists, and biologists. Everybody is researching on this subject. And I realize it's extremely difficult to dive into the maze of such a matter with one language, and especially when everybody is speaking in their own language. And I would like to decipher the complexity of this matter with material. I hope this is not only a science research, but also like a system research, or finding a common ground, or to understand the system within coastal resilience with the ability, let's say, I would start with my research question. For example, filling the gap of researchers of this different discipline, and also finding out a dynamic material system that can balance marine ecosystem, protect human well-being and existing coastal habitat, and apply various forms of materials on different coastal construction, for example. So materials serve not only as a source of like a resource, it's not only serve as a structure for performance, it not only serve as a medium for experience, it is I hope it's a common language for all parties to communicate and become an interface for innovation. So the purpose of this study is to explore a range of material that creates a dynamic system. The problem I'm trying to tackle is, for those who don't understand or don't know much about coastal resilience, there are currently 3 major type of strategies. One is the traditional gray engineering, and on the opposite side is entirely nature-based solutions. And in between, there are actually a wide range of solutions. I would call them the green-gray solution or hybrid solution. So in the green system, generally is by planting or restoring different type of natural ecosystems along the coast. And currently there are a lot of projects going on. For example, the Sand Motor Project and the Great Reef Barrier Reef Restoration in Australia. And for the gray system, the restoration of the gray system, I think it's pretty straightforward. Nowadays, there are a lot of measures trying to modify the existing gray system into a more ocean marine life friendly by altering the surface texture, the surface arrangement, and also the 3-dimensional form. So for the hybrid system, it's kind of brutal, but it might be effective. It's by putting the seawall next to a greenery and trying to shorten the distance or time that nature need to take to generate a new landscape at the coast. So to conclude the literature review, to compare the gray, green, and hybrid systems. So in a nutshell, gray is good for short term. And the green system is good for the long term, but it takes a lot of money and time, and it's hard to measure the success of such a project. That's why the key focus of coastal resilience study will be on the hybrid system. So my second part of research goes to some of the materials being used for coastal construction. They're mostly silica or concrete-based material. But most of these materials are highly engineered, and they don't really work well with the marine ecosystem. So here are two aspects that I'm looking at for such a material. One, they have to fulfill the engineering performance in terms of structural performance. The second part is they have to be ocean friendly. So I looked at actually more than 100 materials, and I picked out 5 latest I say patented material in America. And I compare them with traditional coastal construction materials in terms of structural property and their production method, fabrication method, and their adaptability with the marine life, and their where can they be applied, and their lifespan, etc. So this map will be maybe too complex for everyone to understand, but then to compare them in terms of recruitment of marine life and their mechanical performance, I think among all of these materials, bioconcrete and the biorock ranking really high in this system. So I also took a look in the design world and trying to figure out what designers or architects are doing in this area of research. So there are a lot of architects and designers has been researching on complex geometries using 3D printing or additive manufacturing to create biomimic forms that will recruit marine life. And also there are landscape designers and architects developing new way like biorock and this reef accretion method. These are all what I call the biofabrication. And also there are different designers. They're trying to create unique 3D forms that can attract different type of marine life. So my research will end up hopefully in a systematic approach for material that's sourced from the ocean. I will start with that. And then would start to develop groups of material or what I call material ideas that will do different combinations that will generate different effects for different type of strategies. So the idea is to group different materials in terms of structural performance, and I would add on I would test on different performance such as ocean friendliness in terms of their composition. And I will also look into their manufacturing method to see if they're carbon neutral or carbon negative. And I will map such material back to our coastal resilience systems such as gray, hybrid, and green. So in terms of mechanical properties, I've been looking at both natural materials and engineering materials. And these two maps of material give us a general idea of how all the natural and man-made material system actually look like in terms of mechanical properties. And my final work will also be looking like this, but in a serious map, I would say, like for example, like coral and the shell that combine with cement and marble, for example. So as a designer, I think material is a starting point to investigate such a big map of coastal resilience. So I have two users, one is human, the other one is marine life. I would like to investigate the common ground for programs such as coastal park or coastal facilities like pier, park, beach, housing, and seawalls, for example, that would be facilitating both users. And in terms of these applications, I would also look at both hard, soft, and especially hybrid systems. So in the end, I think my project, because this is only my first semester, I will be hoping to get interesting cookbook of ocean source material and what type of system they can generate. And this hybrid system should be able to help designers, engineers to use it for future creation. So hopefully my output of the paper is not just one material on just one strategy, but rather a multiple strategies that's systematically organized, and it can correspond to this dynamic situation that our coastline is having. And hopefully, yeah, I would be getting some feedback from you guys. Thank you.
Thanks, Leela. And I also wanted to mention someone I didn't mention before, that's Biana Bogosian, who's also been part of the NSF initiative along with Shaheen Vasig. Let's move on to our final presentation, which is going to be a presentation that's been pre-recorded by Bhavleen Kaur. Many of you will know Bhavleen. Perhaps we can, sorry, can you unshare, Leela? Thank you. Many of you will know Bhavleen for Digital Futures. She's been part of the central part of the team. And let me just quickly play the video by her. We might not have any time for questions at the very end. We're running a long way behind. Just to remind you again, if you want to go and information on the FIU DDes, it's on this, if you scan the QR code on the left-hand side here. So this is the presentation by Bhavleen Kaur. Oh, hold on, sorry.
Hello, everyone, and thank you for this invitation, Professor Neil. As Neil mentioned in the introduction, I have a background in architecture, computational design, and digital fabrication, and I have taught and practiced these fields both in India and Spain over the last several years. My current research at the DDes program focuses on material and time-efficient design of tensegrity structure using robotic fabrication processes. During this presentation today, I'll be talking more about some of the concepts behind these tensegrity structures and how robotic fabrication can be leveraged to work with these materially efficient systems. Material systems and their embedded intelligence has been widely studied in the field of architecture and engineering. In the 1950s, Frioto's work on lightweight tensile membrane structure pioneered the integration of physical form finding and material performance for on-site construction, as seen in the most popular Munich Stadium project. Following that, early 20th century designers, architects, and engineers among Buckminster Fuller, Felix Candela, Miguel Fisac, and Sergio were amongst the first to stray into the discipline outside of the formal architectural practice and seek solution for a lightweight and high performance architecture. They borrowed ideas from nature, biology, mathematics into these structures that were that resulted into innovative and unique architectural geometries. These particular structures they were rapidly deployable and modular and were self-forming. The similar kind of concepts can be seen in the more recent projects that happened in the last two decades with the adoption of computational design, digital fabrication techniques, and more recently industrial robots in architecture research and practice, which opened up new possibility to build lightweight structures that are highly complex and yet materially efficient due to the multi-axial properties of these tools that are available for fabrication today. These technologies further enable the exploration of natural materials and lightweight structure for sustainable architecture. This brings my research to a particular context, and I situate my research at this intersection of lightweight study of lightweight structures such as tensegrity, at the intersection of cutting-edge tools of computational design and industrial robotic fabrication techniques. In this research, I aim to present a design framework to create a catalog of spatial typologies with self-organizing tensegrity grid system. This research also utilizes a lot of qualitative case studies that have been undertaken, in particular the works of architect, designer Rene Motro and artist Kenneth Snelson, due to the potentials of the structures that and the assembly potential of these structure in particular. As seen in this image over here, one could see the challenges and also the capacity that just purely the assembly process can bring into the into self-forming of these tensegrity grids. The following research that I'm going to discuss now is based off of my master's thesis project at LSE.
I seem to have lost the sound on that. Can anyone else hear the sound?
Neil, I think the video is paused.
Say it again, sorry?
I believe the video is paused.
Okay, let me just try and see if I can.
Elisawa School of
Okay.
Design for Advanced Design and Digital Architecture program. This research looks at tensegrity system and their self-organizing capacity under a given set of extrinsic forces. These studies include single module studies, multiple module and proliferation studies. They also include the behavior studies in combination of multiple modules and the assembly processes to reach a grid typology. These studies were further diagrammatically planned out to understand the various factors and various parameters that were involved into these studies, which were further taken into a computational workflow that still constantly kept evolving through the physical form finding process, ultimately leading to a geometry which could start with a planar grid, but if actuated and if some of the parameters are changed in terms of the tension of the members, one could start to see the possibilities of form that can be achieved. On the rightmost bottom side corner is the actuated part after all the tension members are pre-stressed to a particular degree. These studies can be also taken into consideration in the robotic fabrication process. While they were done manually, the robotic fabrication would allow for many other tectonics to get to play. Eventually, if the digital workflow is further taken forward, it would result into typologies that can be further explored with a robot. What I'm interested in this DDes research is the intersection between this design space and the robot space. The capacities that material behaviors in tensegrity structures such as compression struts and the tension cables bring, in combination with the capacities of the robot, which has a certain kind of collision detection mechanism. It can have a certain reach, it can carry on a certain kind of payload, and also certain kind of tool creation, which further is integrated into a design to robotics or design to construction workflow. One of the examples in which I will be proceeding in the next in the following years is to create a grid typology and start to actuate and read the and do the collision test of struts with these typologies. These are some of the ideas which I believe, if through this kind of a research, it can yield annotative result, proof of concept, and a roadmap basically for the architects and designers to work with lightweight habitable spaces, while also exploring the different typologies that can be generated by simple manipulation of parameters which are dependent both in a digital space, digital design space, as well as through the physical interaction of tool parts of a robot or any other digital fabrication technique. Hello, everyone, and thank you for this invitation, Professor Neil.
I think I'm not quite sure what happened there, but we lost the final section there. Let me just, my apologies for that. Just one more time, just to mention that if you want to get further information, you can scan the QR code, and if you want to contact us, you will go to, you can use that. You can get to the FIU DDes site, where Gray Reed, Shaheen Vasik, and myself, you will find our contact numbers there. And if you can't scan that, I would suggest you can send an email to info@digitalfutures.world, and we can forward your email to the right person. We've run out of time in terms of this session. Maybe next time I'll be a bit more tight in terms of our timing. Shaheen Vasik is here with us. I wonder if I could invite Shaheen to maybe say a few words about, especially about the NSF grants that she and Biana Boghossian have been responsible for. Shaheen, would you like to say something?
Sure. Can you hear me?
Yes, yes.
Yes, well, it's nice to see everyone here, and thank you for your presentations. The scholarship that we have actually is an NSF fellowship, and it's a almost a research grant that pays $32,000 stipend per year, and supports tuition and stipend for 2 years. So we expect, the program will take 2 years if you're intense about it, and the type of support applies to anything that has to deal with the environmental research, and if you're interested in the environment in any way that relates to the bigger picture.
Shaheen, you've been breaking up. Okay. Shaheen, so we lost the last bit there. Do you want to just briefly repeat it? No, we're not getting. We're not getting the signal properly. I just want to say that Shaheen's NSF fellowship, you can find details of it under funded positions on the FIU DDes website. I think we need to wrap things up here. We haven't had a chance for questions, but you can certainly email us as questions. I just want to thank the presenters today for the presentations. I also want to thank both the Digital Futures team who have been behind making this event happen, and also the FIU DDes, my colleagues in FIU who were responsible for the FIU DDes. And let me just briefly mention, I've mentioned Biana in addition to Gray and Shaheen so far, but Thomas Spiegelhalter has been central to everything that we've been doing, Roberto Rivero, John Stewart, Eric Peterson, Alfredo Dandia, the Dean Brian Shiner, and also Jason Chandler, who set this whole thing up, was the architect in many ways for the whole event, and Henry Rueda, who's now the chair of architecture. It's very much a team effort, and I want to thank colleagues for all of that. This has been, I think, what we're trying to show you today is a very different alternative approach towards how you can do a doctoral research. Increasingly these days, a doctoral degree is required in order to get academic posts, and there's a demand for doctorates themselves. And what we're trying to do at FIU is offer a flexible system whereby academics who are in post can remain in post and continue their doctoral research alongside that, or indeed those working in office practice. There's also the possibility of coming to Miami and working in the RDF lab with Shaheen, Biana, and others. Next month, we have another session inside Harvard GSD, where we'll get yet another different approach. Harvard, of course, has both a DDes and a PhD program in which there are candidates looking at the question of computational design. My apologies, we've run over time, but thank you so much for joining us. I look forward to seeing the next in the series. I think it's been very exciting to go and get a glimpse of what's going on in the kind of research that we've been doing. I look forward very much to seeing what we're going to have when we move to the Harvard GSD session next week. So thank you, everyone, and please send your any further questions to us via the links on our website. So thank you, Shaheen. Thank you, Gray. Thank you, Digital Futures. Thank you, Biana. Thank you, everyone else who's been involved in this effort. It's very much a group effort. So thanks, everyone, and see you soon. Thank you.
Thanks, Neil.